Now I'm off mute. Ah, good afternoon, everyone. Welcome to our fourth lecture. Apologies for the late start. I had to reboot my whole system to solve some technical issues, but I think we're good now. Let me fix that. Why does pulse video do this to me?
Nope, muted again. No sound.
All right, this time for sure. Good afternoon, everyone. Apologies for all the technical issues. I think we're good to go.
Yes.
So, first, welcome to anyone who's joined the course. My email has links to course recordings. For anyone who's having trouble joining the course forum, yes, we want you in the course forum. Please see the instructions at the end of my email for joining the course forum. Everyone should have access to the course forum. All right, Monday, public holiday in New South Wales. No UNSW classes on Monday, including our lecture and a couple of tute labs. I'm going to get through hopefully enough in this lecture for you to work on Monday tute labs. On next week's tute labs. People with Monday tute labs will send email about separate arrangements. All right, so next week's tute lab you'll be writing shell scripts, so let's get into talking about shell scripting. So shells have this bimodal existence. They're interactively used to execute commands. So we sit there, we type a shell command, and the shell does it. Let me flip to a window and run a command. In fact, I'll run the clear command, and then I run the date command, and the shell runs it. That's one way shells get used. Shells are a bit weird in that they have an almost two-part existence. They get used almost equally to run programs. So other programming languages, you primarily write programs in files, but it might be possible to run them interactively. Python would be an example. Perl would be an example. Perl you don't often do stuff interactively, but you can. Python people do interactive a lot, but they much more often write scripts. C you can't do interactively essentially. So shells sort of 50-50. Sometimes people type it, sometimes they put it in programs, and we're going to talk about programs at length in this lecture. What shell? You mentioned there are a few shells out there. We're going to talk about the common subset of any shell you're likely to meet, and that's essentially the POSIX standard shell features. But it's the core features you'll meet in every shell, wherever you go, whatever you do, I expect. We'll mention a couple of things that are less standard, but we'll note that when we do. This is sort of important. Well, there's I guess two things I'd like to see. This use interactively and this use as a programming language results in some shells not being making design decisions that are not perfect for either use. So when you're using the shell, particularly I guess more when you're programming, because the shell can be used interactively and it's got to be able to be used interactively. Some of its error messages aren't so great. Some of its control structures aren't so great. There are design compromises. There are things that if you're designing a shell language and it was only ever going to be used for programming, for writing scripts, there are things you wouldn't do. Similarly, if it's only ever going to be done interactively, there might be things you would never do. So it's a compromise. It's a very interesting compromise. It's a very powerful and useful compromise. So a shell reads a line of input, applies transformations. We're going to talk so much about that. Splits the line into words using white space, also incredibly important. It uses the first word of the line as a command name, and it executes the commands passing other words as arguments. We're going to do a deep dive into these things in this lecture, because you need to understand this completely to be a good shell programmer. There are a lot of people who don't understand it, write shell scripts that break. We don't want you to be them. We want to be the person who knows these things and can write robust, secure shell scripts that work. So, there's a series of transformations. We're going to go in, as I said, we're going to dive deep into these that get carried out in series. So you're going to have to come back to this. You won't understand it at looking at in this go, but you should come back and reread this and understand that this sequence of expansions occurs when the shell reads a line. It does these 7 things in a row, with certain exceptions, and you need to understand them if you want to be a good shell programmer. So you need to understand all of these 7 operations that are occurring, these 7 transformations that are occurring, and see the effects of the order being the way it is. Right. These transformations are a common source of security holes. It's a really common to see a security exploit report which depends on something up here, a programmer who hasn't thought about something in these transformations. Now, one take-home message might be, if security is incredibly important to you, if security is a very high priority for a circumstance, the importance of security varies. You're working in a bank protecting accounts with millions of dollars in them, yeah, security is incredibly high priority. If you're in a university doing research and things like that, maybe it's less of a priority. It's your home laptop, less of a priority. But shell is better avoided if security is your biggest priority. Why do we still have, well, why do these shell scripts still appear in exploits? One of the things that they get appear is that they're part of a privilege escalation system, where the exploit, the security exploit, might involve something that gets the attacker into the system. Then they might have to use a shell exploit to become a different user, and finally they might exploit a kernel bug to achieve what they want. So it's common that security exploits involve multiple levels, multiple vulnerabilities, and it's common that these parts of shell supply one of them in these complex security attacks. Don't worry, we'll work through these things slowly with you and help you avoid them. Alright. Let's introduce you to a program. So let's do something easy and friendly and easy to understand. Let's introduce you to a program called Echo. I'll run it over here. Maybe make this a bit bigger. I can say Echo, hello Andrew. Alright. Echo is not a program you use a lot interactively. What does it do? It takes its command line arguments and outputs them to standard output. You might be saying, look, I think I could write that, Andrew. I think I've got implementations here in C and Python. So for your C programming pleasure, there is a C program that writes out its arguments to standard output. And there is a Python programming that does the same. You can view those at your leisure if you don't understand them immediately. Now you might be thinking, yeah, all right, so somewhere there's a compiled version of one of those, is there, or something like that? And that's sort of a yes and no question. Yes, there is this is a compiled version of echo.c probably, or someone else's echo.c. I just wrote the one I showed you. So that's probably C code that does echo. But echo is actually, for efficiency, because echo gets used a lot in shell scripts, it's often built into the shell to avoid the overhead of running a separate program. So if I can ask this shell what echo is. Oh, I thought I could say that. No, what do I have to say? Is it type? Ah, there we go. It'll tell me echoes a shell built in with this shell. Alright. What do we need to know about echo? Not a lot. We can give it, say what we like. If we don't, it's often we don't want a new line, so we can say -n to echo and get rid of the new line. That's a pretty common thing to want. Sometimes we want to interpret escapes in the string, and we can say echo -e, and it will interpret escapes there. I'm not sure how standard that is. -n is everywhere. -e I'm less sure about. But there's -e telling echo every time it sees \n there to output a new line. I should mention, less portable than echo, but pretty much everywhere, is a command line equivalent to printf, called printf, which is like echo but more powerful. Well, anyway, I'll leave printf as an aside. If you want to explore printf, you can go off and explore printf. It's not POSIX standard, but I've never been anywhere that doesn't have this command line printf, and it can be a bit more robust to use than echo. Echo-e, okay, I think I have been on shells and little embedded systems where that didn't work, but printf has always worked. That's all aside. So echo we'll be using to output things in our shell script. Let's go back to my slides. Shell variables. The shell has variables. They are untyped. No int, no double, no char star. They are untyped. You can think of them as strings. So that means a shell variable containing 1 and double quote 1, there's no difference. Shell variables are not declared. You don't say you don't say beforehand you're going to use them. So if you're coming from C programming, before you use X as a variable, you've got to say what type X is. Shell variables, you don't have no type, you don't say that you're going to use them. They don't need initialization. The first time you use them, the value is an empty string. Why these things? These things look a little risky, a little dangerous for a programming language. Maybe not great decisions for programming languages. They're great decisions for working interactively. So if you're doing stuff interactively, you don't want to declare variables, you want your variables initialized. So these are the decisions you definitely make for interactive use. They work okay for a programming language. So we'll see how it goes. You can, one of the things that this course is for you to see what it's like to program in shell, see what it's like to program in another language, and get you a better view of what's good and what's not in a programming language. You've seen C, Python probably. Let's look at a different programming language. Widen our worldview, come to a deeper understanding of what's good and bad in programming languages. Right. There are, well, not much in the way of local variables. We will see functions later. Functions are sort of tacked on to shell. We'll see them later. And we'll see subshells, but again, that's not something we do much. Generally, we're talking one namespace, just global variables. If I want the value of a variable, I whack $1 before it. So $name is replaced with a valuable variable of name. I want to give name a value, I assign to it like that. Let me put this into operation. Actually, let's do it over here. Let's clear my screen. So I have the variable Fred, and I'll give Fred the value 34. I can say echo $Fred, Now it's not echo that does that expansion. The shell sees the $Fred as one of its transformations and gets the value of Fred, which is 34. If I say echo $Denise, or Debbie's, doesn't really matter, you'll get an empty string there. So that's, I didn't have to declare Fred, I put a value in it, that's fine. One thing to be aware of is you can't put spaces around the equals. You might be used to doing this in your programming. Don't put spaces there. If you put spaces around it, it thinks equals is an argument to Fred. Yeah. So it's a good question from Daniel in the chat. That says run Fred and give it the equals. I can show it. I can show you that. So this doesn't assign 56 to a variable called echo. That runs echo. But this looks like a assignment statement. Now, echo would be a bad choice for a variable name. It's a bit confusing in your program because it's also a frequently used command, but you could do that. And then you can say echo $echo. Let's get all right. Let's go back to token shell. Oh, let's talk a different sort of expansion. This is where the shell gets fun. Now, dollar we saw used to say, oh, there's a name will follow me, replace it with the value of that variable. There's a few things we do with dollar. Dollar gets used in the shell to say replace me with something, but the somethings vary a lot in nature. Dollar round brackets, one round bracket, dollar two round brackets, still to come. Dollar one round brackets has an extraordinary meaning. It says whatever's between me, execute it. So what's between me, execute it. Whatever you get on my stood out, that's my value. So we could do that with an assignment. A equals, and you can pick any program you like to run at all. Date's the only one I can think of. I have such little imagination. And that's run the program date and put it in A. And if we echo $A, we'll get that date. So we can save the date in the variable A. We can save the date, current date in variable B, and we can look at them now and maybe get the current date as well. And you can see they've changed a little there. So we can run absolutely any command there and capture it. Can be quite complicated, so we could say what's one we could do? Well, let's go back to our filters. We want all the usernames on the system and we'll run them for sort and unique. We could do that. Except I forgot the dollar brackets there. The dollar. And that's captured all the system usernames like that. And these are all the particular users on this system. Beautiful. So we can put an arbitrary command between brackets, run whatever it is, capture all of its output, and that string is what we get. And we can then use it anywhere we can use a string. We can pass it as an argument to another program. The simplest other program we've got is echo, but we can run any program, get its output, and make that a command line argument to a separate program. Interesting. Right. Oh, I should mention there's an old way of writing this, which is 2 back quotes. You'll see that a lot if you look at old resources or people like me with old habits. So you can do this as well, and that does the same thing. People don't use single quotes anymore. Dollar bracket is considered much better because you can nest dollar brackets. Single quotes, you can't nest them. So, whereas you can nest because the end and the start markers are different. You can nest, but when you're reading, you'll see that. All right, some important shell syntax. Single quotes stop all special interpretation of the characters within them, and they give you a single word. So variables, commands, and arithmetic, all things we're yet to see, they're not expanded inside single quotes. Globbing and word splitting does not occur inside single quotes. Again, we'll explain what these are, don't panic. You can't put a single quote within inside single quotes. You can put double quotes within inside single quotes. Double quotes are almost the same. Some of your Python programmers will be going, double quotes, single quotes, aren't they the same thing? And C programmers are going, what the hell? Yeah, they're nothing alike. We're closer to Python than we are to C here. Single quotes are for strings in shell. In C, they give you ASCII values. Double quotes are strings in shell in C. Single quotes and double quotes, both for strings. The difference between double quotes and single quotes is if something looks like a variable inside double quotes, it gets expanded. In fact, variables, commands, and arithmetic, all these things that begin with $, get expanded inside double quotes. Yeah, don't panic, we'll explain what a few of these words mean. And show you some examples. Oh, this is a weird one. I'm not sure why we're mentioning it here. There's another way to get a string in shell. Python sort of reacted to this and came up with a better way to do things than this with triple quoting. But this is called a here document. You don't need it for next week's lab. You might not need it in this course. It's such a weird syntax. This says I want a string, and I use that word to mark the end of the string. So you use this in the same place you might use triple quotes in Python to get a multi-line string. If you need to put single quotes around the marker, or variables get expanded inside the multi-line string. No worry, we're going to put all of this together. I'm covering through a lot here. Arithmetic. The shell has some limited arithmetic. And you're thinking, well, wait, how? You said the shell only has strings. How does it have arithmetic? In C, we've got ints, we've got doubles. We do arithmetic on those. In Python, same thing. Well, more or less the same thing. You have numeric types. How can you have arithmetic and not numeric types? The answer is the shell will get the string, convert it to an integer, and do the arithmetic. Let's try that out. Let's make this. So if I say x equals 3, I could also say x equals 3. They're exactly the same, or I could say x equals 3. All of those three things are the same. Y equals 4. I can now say echo $x, $y. But I can do some arithmetic, and the syntax is a little strange. $, 2 round brackets, close the 2 rounded brackets, put my arithmetic in here. And my arithmetic is, well, could be 4 plus 5, which is fine apparently. But I can say $x times $x plus $y times $y and get 25. Now there's one nice thing that makes this more readable is inside the 2 round brackets for arithmetic you can omit the dollar signs. So it makes your code a little bit more readable. So all of this, what's here, better look like an integer arithmetic expression. If it does, the whole thing will get replaced by its value. So all of that becomes 25. I guess you're wondering, well, what if it isn't? What if it looks something like, actually no, that will, what if x contains Andrew? What happens to that then? Oh, I seem to have evaluated to 0. Interesting. If y contains Fred, I'm not entirely sure what's happening there now. Which is a little scary, isn't it? So there's not strong checking of our arithmetic. It's if we have code that has to do a lot of arithmetic, we should be flipping away from shell. We should be coding it up in another language. There's a few reasons for this. One of them is you've seen here just weird behavior. So yeah, we might have a loop that needs to count simply or something like that. That's okay. Complicated arithmetic in shell, no. There is another thing, is arithmetic in a shell is really slow. 1,000 times slower maybe than a C program. It's a bit hard to estimate. It's got to do a lot of conversions. Every time it sees a variable, it's got to flip it from string to integer and back again. So arithmetic's there, but we only make limited use of it. Having said that you will make use of arithmetic in next week's lab, and we'll work through an example of it shortly. You might be saying, well, Andrew, if it runs 1,000 times slower, why did it ever use shell? It's quite possible that if your program's just counting, that 1,000 times slower still has no impact on the speed of your program. It's also possible, you're doing, matrix arithmetic, fluid flow calculations or something like that. It's dominated by the speed of arithmetic. But a lot of the programs we'd write in shell, the arithmetic is a very minor cost, and it doesn't matter what speed it runs at. Alright. Don't worry, we'll get to writing some more satisfying programs shortly. To try and help us understand what's happening, I'm going to try and run with word splitting. Actually, no, will we get the word splitting? I don't want to do word splitting first. Maybe globbing. I'll do globbing, and we'll come. Oh, alright, we need this for. We'll do globbing first. I'll show you the program, and then we'll get to this. I have here No, I don't have here, but I will have in a second. Actually, I can just get it here. It'll be... Oh, interesting. So that's a little bit of Python that does almost nothing. It just prints out its argv, what has been passed to it, in a form that makes it clear what's there. Let's try it out in the other window. Print argv.py. Let's just say that. There we go. So these argv is an array. You'd get this from a C program as well. First element of the array is the program name. So the program knows how it was invoked. And then the next two elements are the command line arguments. So this would be argv1 and argv2 in a C program. In a Python program, it's sys.argv. So let's review this. I've run the program here. The shell is founded as ./that. Interesting. We'll come back to that. We'll talk about why that dot's there and what it says. What about I want to pass that as one combined string? I just want to pass one command line argument that says hello Andrew. I can do that with single quotes like this, and we'll see what gets passed through to my Python program. Or if you prefer, with double quotes. The single quotes there are just Python's way of saying what its command line argument is. And just to show you a stupid way of doing it, I can say to the shell, ignore that space. And I'll pass it through 3 ways. So what's happened here, I'd call that word splitting. And single quotes and double quotes stop that word splitting happening. Oh, there's a few. Alright, I want to show you a few more things. Let me show you arithmetic happening. Let's put some arithmetic there. 6 times 7. And you'll see the Python program never sees the dollar and the brackets. All of this is evaluated by the shell, transformed by the shell into 42. Nice. Let's set a variable. Let's set a. Oh, we've got x and y there, don't we? So let's pass through x and y, and there they go through. So Andrew and Fred go through. Let's put single quotes around. Oh, that's the value of x and y, by the way. Let's put single quotes around the $x and double quotes around the $y, and let's see what gets through in argv to our program. So if I put single quotes around this, that says no transformations. Shell, one word, no transformations. We'll make it clear it's one word by putting a few more random words there. Hi, $x. So you'll see this getting passed through in one go there. But up here, the y gets replaced by its value and goes there. Let me show you, demonstrate also, seeing is believing. We'll put arithmetic up there and see that get transformed. So that won't make it through, even though it's in double quotes. That will get transformed, and we'll put the date program there in like that. Like we'll put three things. We'll have three transformations happening at once. We'll do it in 2 goes. Alright, it's a bit confusing, but Y got transformed to Fred. 6 times 7 got transformed to 42. That got transformed, the date program was run and got replaced by its standard output. So the standard output of whatever that is, finishing up in argv0 of this program. All those transformations can happen inside double quotes. In single quotes, nothing happens. The exact characters get passed through as one string, one word in argv1 to the program. I cannot encourage you too strongly to work through all these sort of examples of this to make sure you understand what's happening with single quotes and double quotes. This dollar here, that's the prompt. Yeah, there's a few good questions, sorry. Some people are saying, yeah, what's the value of Y? The values are retained, so if I can give Y a different value now for you. Y equals well, I can see Justin in the chat, so I'll give Y the value Justin. And if we print that out now, oh, it's double, that's single quotes, so there's no evaluation. We'll go back to the one with double quotes with evaluation. And there you can see Y now changing to its, having its replaced with its value, which is Justin. Here we go. Alright. Now, that was all good. Alright, I wanted to show you something which has the fantastic name of globbing. Globbing's very useful for interactive use, and a little use, well, it's something we certainly need to know about for, I don't know, you use it in scripts as well, but you've got to be careful about it in scripts. So let me show you globbing. Let me create some files first. I'll just create some random files, a.c, b.c, actually we'll call it, actually let's give them main.c, functions.c, i.h, j. What's in one more file? Alright, I've created a few files. If I run ls, it'll show me there. Touch, by the way, is a program. You'll see it used in a few examples if you haven't seen it before. Touch creates a file, and if the file already exists, it sets its modify time to the current time. So if we need to create files for a little example, you'll often see touch used. Now, asterisk has a special meaning to the shell. If the shell sees asterisk in a word, it will replace it. It will replace the string by all the file names that match. And it's worth running our printargv program. Oh, actually, no, we'll do it over here to avoid running into my head. What gets, if I say this, what gets passed through? echo.c, f.c, functions.c, main.c. So the shell saw this and applied a transformation. Let me go No, we'll stay here. We'll work through a few globbing things, and we'll go back to the order of transformation. That's important. Now, let me talk history for a little while. It used to be that this sort of behavior, being able to say pattern dot blah when you're talking about files, remove files making this pattern, move files making this pattern, compile files making this pattern. It's so obviously useful. It used to be programs did this themselves. So the program would get star.c in its argv from the user and say, I'll expand that for the user. And that was horrible because some programs did it, some other programs did it slightly differently, and some programs never did it. So you'd use things like star.c and we're never quite sure what was going to happen because it was implemented inconsistently by the individual programs. Then someone realized, well, that it was better to do this in the shells, and Unix shells have done this from the start. If you do the expansion in the shells, then it's not up to the individual program, it's all done consistently. It's great. Joseph, I've got some terrible news for you, Joseph. Joseph's saying, wait, asterisks, we saw asterisks in regular expressions. Yes, we saw asterisks right up the start in our where we first ventured into regular expressions. Asterisk has a very important meaning in regular expressions. It's different though. Yes, it's different. This is not a regular expression. This is a file glob. Yes, they use the same character. Yes, this is incredibly confusing. Yes, whoever did this wasn't thinking of COMP2041/9044 students. It's scary, but you've got to know, is this a regular expression or not we're talking about? It's a different syntax, a different meaning. So this gets applied to file names only. You could have actually put regular expressions here. Impl matching you generally want here. It's not as powerful as regular expressions. There have certainly been people who have developed their own shells and said, no, I'm doing away with file globbing, we'll just have regular expressions. But it's never really taken on. I'm not sure why. If this is a regular expression, the equivalent here would be .*c.
One of the main issues with using regular expressions in the shell is that most of the time you want file names, and file names have dots as a normal character, and regular expressions have dots as a special character, and you'd have a lot of escaped dots in your regular expressions in the shell, which you really don't want. So globs were designed specifically that dot was not a special character.
All right. Now, I should say, by the way, most programming languages have access to file globbing. There are libraries you can do file globbing. You can say there's a library function. You can say, look, here's star.c. Tell me what that turns into, and it gives you back a list or an array containing echo.c, f.c, function.c, and main.c. In Python, that's glob.glob. What's it called in C? I've forgotten. Is it just glob in C? I think it might be glob in the C standard library. But most languages have it, just like most languages have regular expression libraries. All right. What else can we do?
Just glob from glob.h.
Oh, there we go. Glob and glob.h. What else can we do? Question mark. Also a special meaning in a regular expression. Also a special meaning in globs. Different meanings. Question mark means any character, which is dot in regular expressions. Dot in globs has no special meanings. It's awful, isn't it? There we go. So that star dot question mark matches any file with a one-letter suffix. And I can say question mark dot question mark and match any file that's any letter dot any letter. So that's question mark. These are asterisks and question marks are the ones you'd use most. But there is another one. Square brackets have the same meaning. Small mercy, small piece of good news for the poor student trying to wrap their head round without all these things without their brain exploding. Square brackets, same in regular expressions, same in file globbing, means any one of the characters between them. And there we go, it matches a C or a H. Yeah, so those, and actually these are, I use these on the command line all the time. So these are things, remove files, move files, things like that. You use them interactively all the time. Less so in scripts, but you do use them in scripts. So really useful things to know, both because we want to be able to power our user interactively on the command line and for our scripting. So file globbing, really useful. Just don't get it confused like regular expressions. Blake is saying, can you do ranges? Yes, you can. It's not something you do so much, but you can. This, I almost never use that, but you can invert what's between the square brackets. Alright. Let me show you something that may be an issue for you. If I say, well actually no, we'll do it with print.v, that's quite nice. If I say all the .text files in the current directory, there are no .text files in the current directory, so that glob matches nothing. Now, think about this. What would you do in this circumstance? There are two possibilities which I'd expect you might have thought to do, and the shell does a third thing. So one thing you might think to do, one natural thing to do, if I gave students and said, how are you going to design a shell to do this? Error. So you might print out an error message saying, oh look, didn't match, Andrew. Something's gone wrong. There's no .text files. So that's one possibility, and perhaps not run the command. So super obvious. There are shells that do this, and this shell can be configured to do this. There's an option to say do this. That's one possibility. The next possibility, and that's maybe what you want or maybe not interactively. Why don't you want it sometimes interactively? Well, let me show you when it's useful. Sometimes you forget and type this. Now that's actually a file glob. Yeah, and if I was a careful person, I should be putting quotes around it. But often people quickly type it on the command line and forget. And the shell designers decided to be careful, decided to be helpful, super helpful, maybe a little scarily helpful, and said, all right, we won't give the Andrew an error if he does this. Now, there's a second possibility that you might think is, well, if star.ch turns into all of these things, star.text should turn into nothing. So we should just get this. You might think I should get that. That would be good interactively. And again, there is ways to tell the shell to do this, that particular shells can be configured to do this. That would be nice for scripting. But what the shell does is the third thing is it just leaves it unchanged. That means if I say grep a.star.b in this, what do we look for? We'll look for a print statement. There we go. This gets passed through unchanged. So that means if I forget to quote a regular expression, if I forget to tell the shell this is not a file glob, the shell will then try to file glob it, fail because no files match, and then pass it through unchanged, and my regular expression will make it to grep. Does that sound brittle, error prone, a little dangerous? Yes, it does. It is what it is though. Alright, it's something we need to be aware of. You may configure your personal shells, or when you're scripting avoid this, but you're still going to be so aware of this in general when you're working on systems. So it's something you need to know about, even if you set things up so it doesn't happen. All right.
There's a very, very important reason why globs don't disappear when they don't match. Because as we talked about last week, most Unix filters, if they are not given anything, will read from standard input, which means that if you have a Unix filter, you put a glob after it, and it doesn't find the file, suddenly the entire action that Unix filter is going to do changes. It's now going to wait for standard input instead of reading a file. And that can cause shell scripts to just sit there indefinitely, waiting for standard input that they're never going to receive. So that's a very, very important reason why that doesn't happen.
Yeah, that's a lovely insight. So look, I've set up this circumstance. I've said star.cc. I've told the shell replace that by all the files ending in .cc in the directory, all the C++ files in this directory, no C++ files in this directory. I've said there are two natural options. One is give me an error. So just the shell just give me an error saying I can't run that command. That's a possibility. I've said in scripts we might want this to turn into empty, but Dylan's pointed out a major problem if that were to happen. What we get is this, but if it turned into nothing, grep would then sit there trying to read from standard input. All right. Experiment again with all of these things yourself. Try doing glob matches, test them out, test your understanding, make sure you see what happens. All right, I think now we've covered. I can go back and look at these transformations and view them. Back. All right, so these are the things that happen to an input line in shell. Anything beginning with $, followed by a name, gets replaced with the value of that variable. Anything with $single brackets gets replaced with the output of running that program. So the program between there, a separate program is launched off, run, whatever it put out and stood out is put there instead. So this could be something that takes runs for minutes or hours. This could be a huge operation. This is a gigantic difference with C programming. When you're C programming, generally to execute one line takes just a few instructions of the CPU. So we're talking picoseconds, whereas this could take minutes to execute. All right. $, and two brackets, what's between it is treated as arithmetic and replaced by the value of the arithmetic. The line is broken up on white space. Globbing occurs. IO redirection, which you haven't seen. IO redirection also occurs, and that's it. If I put double quotes, none of this happens. So I put it in double quotes, I can stop the last four things happening. If I put it in single quotes, I can stop it all happening. But I've got to be aware, if I don't put quotes around something, all of this happens. If I put double quotes around it, if I put double quotes around it, the first three things happen. That has to be in the mind of every shell programmer. We will show you a program called Shell Check that checks your shell programs for this, but it's a bit early for that. IO redirection, yeah, I forgot the LUN transformation. So this says run this command, but then take its standard input from that file. That says run the command, but send its standard output to that file. Beware, that destroys the file. A single greater than says destroy the file, then we'll put output in it. This says append to the file. We can also redirect standard error or send standard error and standard output to the one place. And this is, if we want to send standard out to standard error, that's a nice trick. We'll see this one in a script in a while. In fact, we'll see both of those in scripts to come. Don't worry too much about them. I/O redirection. You can experiment with those as well. Pipelines. Yeah, we've already seen pipelines at length. So processes joined together with pipes. Path. A path is a standard way shells use to specify where to look for a program. I say to run program X, how does the shell find it? On my system, there can be, well, how many files? There can be millions of files on my system. If I say run program X, where should the shell look for it? If I say date, how does the shell find a program called date to run? It actually finds this program. Is that the only file on the system called date? I don't know. No, actually it won't be. It definitely won't be. There'll be many files called date on this system. Oh, I should have cleaned up my path before showing it to you. Oh, it's got a typo in it too. So I've specified, don't worry about this. This is like, let's forget you ever saw that path. That's too many things. I can say search in /bin/user_bin for programs. So I can specify just 2 directories there. And the shell will find that in this. So the path is a colon separated list of places to search for programs. And oh, sorry, no, that's not what I wanted. I want directories. These are directories. These are directories containing programs. So I've set up, that's not a bad one. And I've said anything you want to run, search those 3 directories for the program. Well, it turns out on this system /bin is just a link to user bin, but that doesn't matter. Alright, so how many programs there are in the user bin? We can figure that out. Oh, there are 4,200 programs. And I've added a few of my own programs in home Andrew T bin. I've got, ooh, that's a bit worrying, 586 programs there. Alright, so that means there are 4,700 different programs that I can run just by typing the name there, and the shell will happily find them there. So that's the path. And then it can be configured for whatever you like. So it's pretty common for users to say look in these system directories for programs, but also we'll look in my directory there. You might or might not want to say look in the current directory. We'll talk about that maybe later. Oh no, let's talk about it now. Yeah, so if I say run program kitten, the shell will look in bin kitten, user bin kitten, home Andrew T bin kitten. You can put dot in your path. If you're worried about privileges, don't. Also beware an empty directory in your path is equivalent to dot. Dot is a name for the current directory. This is meant to show you the perils of, oh, can I cut and paste this? No, but I can do this myself. So we've all seen the standard Unix program cat already. So we can say cat But what happens if there's a program called cat in the current directory? Cat into cat. Oh, we haven't covered this stuff. Don't worry, we'll explain all of this stuff. Cat into cat. Oh, can't run it. Chmod it. We'll explain that as well. So many things to cover. So I've now got a program in my current directory called cat. If my path is set up to be a normal sort of path, if I put the current directory last, that's fine. I can run a program in the current directory like printargv, but when I type cat, I'll get the system cat, which does what I want. Because the shell searches for cat in /bin, /userbin, home_tbin, and the current directory last. If I'm foolish and put the current directory first, bad things can happen. Now if I say cat printargv, I'll get the cat from the current directory first. Alright.
Some people would recommend never putting a dot in your path, especially on a shared system where you don't know what could be in the current directory. If you're on a shared server and you're moving around to directories that other people may have control over, you have no idea what could be executed accidentally if you have dot in your path.
Yeah, so if you're
so you have to be careful.
The system, one of the people who maintains the system with privileges, maybe if you're root, and you're CDing, saying into student directories, you really don't want dot in your path because you don't accidentally want to run a student program. Maybe a student's been mucking around and got a program that goes rm-rf/ and called it cat or whatever, or whatever. You just don't, even if it's the last thing in your path, you want to be super cautious. Alright, we've covered that.
I think it might be a good time for a break. We've been going for an hour.
Alright, let's have a break. We'll keep it, 5-minute break. Alright. So we'll be back in 5 minutes. Let's get up, stretch, and we'll get back to writing scripts. Alright, hello everyone, welcome back. Hopefully we can now take you through writing our first shell script.
This is a reminder to correct your path before you try to run anything else.
Oh, thank you, Dylan. Alright, I'll fix my path. So let's write a shell script rather than up till now we've been typing shell commands. So let's write our first script that does something. We'll put a hash bang line on it. So on Unix-like systems, the operating system looks at the first 2 bytes of a file, and if they have the ASCII values for hash and exclamation mark, it then takes the next line up to the new line character as a program to run to interpret the file. This can be anything. So you'll commonly see Perl, Python, Shell there, but if you invent your own language, you can put the path name for the language interpreter there. We could run the program by saying to a shell, these are shell commands, but this lets us run standalone. We'll say echo hello Andrew in it and try it out. I'll try it as /hello.shell. I think it's not going to work because I don't have execute permissions. Yes, we can see it doesn't have execute permissions. Let me show you no execute permissions. There. This is permissions for me, no execute. I can fix that. This is the mode I'd normally use. Oh, I probably should show you how most people use symbolic permissions. That's how most people would write it, but either way we'll get what we want. Execution signal that the file is executable, and there we go. So there's a shell program running, producing some output which says hello Andrew. Great. Oh, thank you VI. Now what can we do here? Right, what we need to know now is about some variables. So we need to do much more. We need to know variables. Shell has some built-in variables for us to use in scripts. $0 is the same as argv0, $1 argv1, $2 argv2, and so on. $hash is argc, the number of command line arguments. There's 2 variables that contain all the command line arguments, $* and $@. You really don't want to use them except this way. What you want almost always in a script, if you want to execute over the command line arguments or pass them on, you want double quotes, $@ double quotes. Why is sort of complicated, but you're avoiding splitting. Why you avoid splitting, like, well, yeah, why you want to avoid word splitting is pretty obvious. Why this syntax avoids word splitting, less clear. But double quotes $@ gives you the command line arguments. Process IDs are here. We won't need those for a while. Let's try this out in a script I've already got written. Here. Let's print out some of these variables, and we'll say .args.h, and we'll say hi, how are you? That will do 4 command line arguments. All right, don't worry too much about these things, but see that we're getting a 4 here to say we have 4 arguments. We're getting our name here. In fact, let's go back to our previous one. Let's change it to say hello $1. And now we can get the script to say hello to Dylan. Or who's in the chat? Jed's in the chat. We'll get the script to say hello to Jed. There we go. So that's our first command line argument getting replaced in there. Let's, because
what happens if we don't give a name to our hello to sh?
We'll do that in a second. Let's access 3 command line arguments. And I'll pick the top 3 names in the chat. Tim, Liang, and K Shaw. I can do that. There we go. So that's accessing 3 command line arguments. You will need to do this in the labs. And in next week's lab, and you might need $hash as well. So they're the crucial ones for next week's lab. Dylan's asking, what happens there if you don't give me 3 command line arguments? Initialized to an empty string, and empty string. No errors, just empty strings for these, for $1, $2, $3 if they don't exist. Alright. That's all good. That's not scary. What now? I think we need control statements, branches. $$ gives you the process ID of the current process. You don't need that next week. I'm not sure what we'll use it for in this course. Oh no, we might, yeah, we might use it in a lecture example next week though. I think I want to show you if statements. We'll come back to some of this. No, come back to that. Come back to that. Exit status. When Unix-like programs finish, they give the operating system an exit status. This is the return value of main. Alright, so if you've been in COMP2041, maybe COMP9024, COMP1521, you've written all these main programs, you've had return values, and you've never done anything with them. You've said return 0 a million times, that it's never mattered. Finally, it matters when we get to scripting. So the return value from main is the exit status of a C program. In Python, it's supplied by sys.exit. The exit function in C can do the same thing. So a program, a Unix-like program, has an exit status. It's usually a tiny integer. 0 is good. 0 is meant to mean things went okay, things went normally, things went everything. I was asked to copy a file, I could do it. A non-zero exit status normally indicates a problem. I was asked to copy a file and the disk was full. I was asked to copy a file, but that file didn't exist. You'd get a non-zero exit status. Let me actually show you that. That's a good thing to show you. So if I say cp, actually we'll do it with something else. Which file we'll use? Oh, we'll say cp hello.shir to george.shir. That's going to work fine. And the exit status is left behind in this variable, and it's 0. But if I say cp non-existent file to non-existent file, the CP will give an error, and it will have a non-zero exit status. of 1 to say, oh, I went wrong. All right. Why does that matter? Why do we need
something
this?
Very important here, which catches people out, is that you need to check that exit status immediately after the command. Because if Andrew was to rerun that command, he wouldn't get a 1, because the last command he ran was echo, and it worked correctly. So checking the exit status generally updates the exit status.
Indeed. All right. The shell uses exit status of programs to control if and while loops. So you use the exit status of programs to control what you do. There are 2 great programs. 2 of my favorite programs is true, prints nothing, and always exits with a 0 status, and its friend false, prints nothing, and always exit with a status 1. So the world's simplest C programs, true contains a main which just returns 0 in it, false contains a main with return 1 in it. Useful only for scripting sometimes. Alright, let's keep moving on to the things we need to get through. So I want to cover everything we need for next week's lab, and then we'll don't worry, we'll recap through these things slowly via examples. The program test we'll come back to. So this is the form of the shell if statement. It's a thing of sort of Baroque beauty. After this, people realized there were a few languages that had this sort of form of using a pile of keywords, and this fell out of favor generally in the decades afterwards. But we have if and phi for the start of an if statement, and then. So every if statement has to have those 3 keywords in shell: if, then, phi, and it's if command, then commands. We can optionally have an else if section and an else section, both optional. If this command succeeds, these commands are executed. If this command exits 0, these commands are exit. If it exits 1, these commands are not executed. If there's an else part, the else part is executed. Let me find the while statement. The while statement is similar. It's while command. So, and the body of the while is delimited with do and done. So every while statement has 3 keywords. While this command has exit status 0, do these commands. Alright, I think I've got a nice so here it's sort of a stupid example, I guess, but here's an if statement that you might use. I've got main.c. I try to compile it with GCC. GCC will exit with status 0 if this is C, and it can successfully compile it. Otherwise, and this is a bit stupid, then we say, oh look, I'll try running it as Python. If that succeeds, we say, oh look, you've written Python. Else, we do this. So that's using an if statement to run this command, and if it works, say that. If this works, say that. Otherwise, say that. This removes a.c if it doesn't compile. I'm not sure why you'd want that, but you can't. It's just because you can't have an empty body to your statement. You have to put a silly colon there. I've never been really clear on why that's necessary, but it is. Duke's asking, wait, Andrew, 1 is true and 0 is false in C, C++, Python, Java. Yes, your world has been flipped, Duke. Why? There are reasons. I guess in programming languages, if things worked, we don't have anything to stay in exit status. So we only need one good exit status. And in principle, you might have a number of bad exit statuses to say what the problem is. So you might exit 1 for file system full, exit 2 for out of memory, exit 3 for no permissions, and so on. So the idea is we want, I guess that's why they chose it, but in the end it's flipped. It is flipped. This continually does programmers' heads in that it's 0 is false in C, 1 is true, but an exit status of 0 is good, an exit status of 1 is bad. And in shell conditions, yes, an exit status of 0 effectively is true. As I said, this isn't easy, but you understand all of this and you can do so much. The world isn't easy to figure out, but if you can, it's incredibly useful. Alright, what would I like to do with this? I think, yeah, I think we'll put if and while together and we'll come back to for. So there's a few things we haven't covered. Oh, alright, we need one more thing. There is a program that exists only to live in shell scripts, the test command. It performs a test or combination of tests. It normally prints nothing. It exits with a 0 exit status if the test succeeds, exits with a non-zero exit test status if the test fails. You can compare strings, you can compare numbers, you can test if a file exists, if it's executable, if it's readable. You can combine tests with and or operators. You can write it as square brackets, which lots of people prefer, but not necessarily me. It may be built into your shell test. So it's the last part of a puzzle. Let's try writing some programs. Let's try using this to write programs. Show you the sort of stuff you need to know. I'm going to write a counting program. So I'll start off with hash bin sure. I'll write it. I'll chmod it so it's executable. Oh, nope. This time for sure. Alright. We'll set the variable I to 1 and we'll do, so there's my while loop. Alright, let's start that off. It's a bit stupid, but alright, so that writes out an infinite number of ones. You're thinking, Andrew, that's a stupid program. Do man yes. Alright, and you'll see that such a program can be useful. It's not what we're after today. So this ran the program true, which always exits status 0, so the program true is being running continually. Let me show you a trick for seeing what's happening here. The shell has a debugging flag. If you say this in a shell script, it will then tell you every command it runs. It'll print information about every command it runs. So it's a simple, crude, incredibly useful sort of debugging. So I say set -x. You may well want to do this when you write your first scripts in next week's lab. I'll put this, and it should show me the programs it's running, and it's just running true and echo 1, true and echo 1. Alright, that was fun. Let's change the true to false, and we'll get a program that does nothing. So the false exited with status 1, so the while loop didn't run. That's great. Alright. So I can use test here to say while $i less than, we'll count to 24. Ah, it doesn't stop. We need one more part of the puzzle. So that's doing that test. That's testing if 1 less than 24. Oh, notice the dash X is given the exact test it's doing after the I has been expanded. So the I has been expanded to 1. We're saying test 1 less than 24. One good thing to get in the habit of your debugging shell script is trying them out. So I can type this here. Doesn't print anything, but I can peek at its exit status, and that's 0. I so encourage you to try these things out. So notice if I ask 1,000 less than 24, I get an exit status of 1 to say false. Here's my last little piece of the puzzle. Let's do some arithmetic. All right. First, a reminder, a big reminder, arithmetic, brackets and brackets. There's arithmetic. What do I want to do arithmetic in? I'll put it there as $I plus 1. And that now should run. Oh, I'll turn off my debugging. Alright. Life advice, you've never found the last bug, so leave the debugging there to be turned on easily. Well, I guess when you hand it in, when you submit an assignment, you found the last bug before it gets marked. So you can remove the debugging when you submit your assignment, maybe. Alright, so that prints the numbers 1 to 23. 1 to 24. I'd like it to be less than. Alright. That's quite good. Let's make it more flexible and pass the limit in. In fact, let's pass the start and finish in as command line arguments 1 and 2. Right. So this is, you could use $1 and $2 down here. That gets confusing and hard to remember. So it's nice style to copy the command line arguments to variables with good names. So now we can say $start $finish. And we could run that. And now I can say count from 10 to 20. Well, in fact, let's make. Are we Python programmers? Yeah, we're doing this sort of like the Python range operator, I guess. Right, counts to 10 to 19. Beautiful. So passing the start and the finish as command line arguments, putting them in name variables, and we're scripting away. Now in the chat, Pernay's pointing out we could remove the dollar inside the brackets. Yeah. Let's see if Pernay is right. Let's try it out. Way to go, Pernay. Yes, and it is a bit more readable without the dollar there, isn't it? Particularly if so that's good. That's our script all happening. Be nice to have an optional step value, so I could put a 2 here and count. Oh, but I have to go to Blake's question there. Blake's saying, well, why double brackets? What does that do? What's that going to print? Yeah, that's not going to be good, actually. Let's try it out. What does that print? It's a good question. What does that print? Lots of error messages is what I'm guessing. Oh no, it stops. Why does it stop? I understand why that stops. Oh, that shouldn't stop. It's trying to run oh, alright. Yeah, I understand why it stops now. That's sort of confusing. It's trying to run I+1 as a program. That's a weird debugging thing. You don't get any types. You see, if you do some later courses, you discover why types are wonderful and types help you out. You have no types helping you out here. You're working on the raw edge of programming without any help. So let's try that out and see if I can understand that. I remove the double brackets. What happens? Single brackets means run whatever there. So the shell said, alright, okay Andrew, let's run the program I and give it arguments plus and 1. Now, there's no program I, so it says I not found. You think, what if there was a program I? I could have an even weirder bug, couldn't I? Yes, you could. So I got set to an empty string, and then this with an empty string failed there. Alright, let's go back in time and do that. But it's a huge difference, isn't it? Double brackets arithmetic, single brackets run the command between me. You've got to try all of, well, that's why we have lab exercises, but you've got to try all of these things. Yeah. Alright, I quickly wanted to try adding a step here. I'm going to show you for loops before the... Don't worry, we're going to work through these things more slowly and much more examples next Thursday. So what about we have an optional third argument of a step? How will we do that? Test $# equals Alright, bear with me, I've got a plan. I can do a bit of argument processing. So we're going 2 arguments, they're the start and the finish. Remember, $# is how many arguments we're getting. We're given 3 arguments, it's start, finish, and a step. If we're not given 3, if we're not given a step, we'll assume it's we'll set it to 1. Alright, I'll put something here quickly, but we might improve on that later. Alright, I'm pretty confident there I have used an if statement for the first time to demonstrate an if statement. Now, I can say count from 4 to 8. Oh, so close, so close. But what I forgot was you have to add a then after the elif. You're saying, oh, how would I know that? How would I know? Yes. Oh, well, actually, it's not too bad. Expecting then. That's better than shells used to be. Yeah, count 4 to 8, and I also say count from 4 to 50 in steps of 13, and look at that. So. Test says, do I have 2 command line arguments? Set these. Test says, if I have 3 command line arguments, otherwise, well, we'll try it out. So that's using an if and the while statement. All right. Let's look at demonstrating a for loop to you.
Oh, I would like to just to quickly mention that someone may be thinking, hang on, aren't we doing string comparison? And yes, actually, that if statement is doing a string comparison, but the string 2 and the number 2 are the same. So fortunately, it doesn't matter in this case. Although theoretically, I think it would be more correct to use dash EQ in those if statements to do numerical comparison.
Potentially, yes. All right. I've moved to a different program, for.sure. We'll get rid of most of this. I still wanted counting in this. Actually, having done that, I'm going to get rid of all the counting. All right, a for loop does, we'll call it J in. You give it a series of words to, actually, no, they're not good words. I'll say cat, dog, horse. A for loop loops over a series of words. Yes, Blake is right. We love types. Types make our lives easier. Types are wonderful things. Why find bugs ourselves if types can find the bugs for us? Now I want for.sure. Alright, so the for loop executes once for each word here. So J is set to cat, J is set to dog, J is set to horse, and the loop executes 3 times. I want to add, so I'll now add counting to the loop to demonstrate that. So we'll set I to 1, and we'll echo $I and $J, and we'll increment I. There we go, counting. That's nice. Now, let me show you looping over our command line arguments. If I put this, I get our command line arguments. That is the programming pattern in Shell for a loop that executes once for each command line argument, which I think is exactly what you need for one of the lab exercises next week. So let's try it out. No command, let's write the file and try it out. No command line arguments, doesn't. So let's give it some command line arguments: zebra, lion, tiger, buffalo. There we go. 4 command line arguments, it executes 4 times. I don't think it's what you want for next week's lab, but a really common thing to see here also in shell scripts is for a script to execute for once, maybe for every C file in the current directory. So put a glob pattern there, and that will execute once for every C program in the current directory. So that's a loop that executes once for the every C program in the directory. Blake is asking, what's the point of shell? Why do I need shell? If you're coding tasks that mainly involve executing other programs, shell scripts are simpler, concise, more easy to write. When would you be in that circumstance? If you're writing scripts that control systems and start systems, stop systems, launch other programs, it's generally much easier to do them in shell scripts. yes, you can launch other programs from C, from Python, from Perl, from whatever. So if you've got to do a lot of computation and then launch the odd program, yeah, you might be better off in Python or C. If most of what you're doing is running other programs, then and you're not doing much computation, then Shell is simpler and faster to write. Shell also has a small footprint, so lots of tiny devices. I've mentioned Shell running inside remote controls. So I'm holding a remote control here. It's quite possible you push a button on this and there is a shell running inside it. It's a bit scary. It's more likely that there's no shell in the remote control, but it's quite likely a shell will run in the TV in response to the remote control. Okay. Assignment 1. Please, we haven't taught you the stuff you need to know to start assignment 1. When we've taught you the stuff for assignment you need to know for assignment 1, we'll release it. It'll probably be the end of week 4 that we release assignment 1. Okay. So that's a for loop. I'll show you one thing that is a bit worrying about for loops here. There are ways around it, but if I say loop over all of the C++ files in this directory and they're none, it executes once with j set to star.c. That can be a bit awkward for some shell scripts. All right, let's go back. Oh yeah, one thing let's go back to my count.sh. I'm expecting some of you will be looking at internet resources trying to figure out stuff like this. It's a normal thing to do, an encouraged thing to do. You may see code that looks like this instead. So square bracket, a single square bracket is a synonym for test. Sometimes it's done just with a single link. I don't know if this system has some systems have a file called that. Oh look, there it is. Is it different to bin test? It might be different to bin test. Oh, it is. Yeah, that's a little weird. But they tend to be almost the same program.
The only difference is that Unix utilities have a name built into the source code. The actual executable code inside those two files is identical.
Okay, that raises fears, but or thoughts at least. So people think this is more readable. I don't. I like for teaching the code to use tests because I think it's more obvious. Command being run, tests being done, and using square bracket sort of hides the reality. But lots of shell coders want to hide the reality, and that's fine once you're used to shell coding. But so that does exactly the same thing. It just looks prettier, perhaps, depending on who you believe. But if you look up code online, look up examples online, you'll see lots of people coding up their shell scripts like that. All right. Let me just go back to the lecture slides to see if I've got anything else. We're going to go work through all of this. Next week's tute will cover this slowly, leading you into next week's lab where you get to practice all of this. You can also practice the things you've seen in the lecture and things like it. And we're going to go back and work through it in next Thursday lectures, work slowly through more examples of programming in shell. And then even then, in the lecture after that, we'll work through examples. If while, that's the example we've just done. The watching the website one we'll come back to as our first example in a week's time. All right, I've rushed through a lot to get you ready for next week, and we're catching up on this. It's the holiday weekend is leaving us a bit behind. Don't hesitate to ask in the course forum. So questions very welcome there. Don't hesitate to try stuff out. Thanks for your patience. Apologies for the slow start to the lecture with my technical difficulties. Apologies for rushing through this. Have a happy Queen's birthday weekend. Whether you, well, we all wish the Queen a happy birthday. I'm not sure it's actually her birthday. Happy shell scripting, writing your first shell scripts next week. Don't forget to submit with Give week's 1 lab exercise that you haven't done, week 2 lab exercises. We're saying Tuesday noon because of the long weekend. The normal deadline would be Monday, but with the long weekend we're saying Tuesday noon. See you all next week. Next Thursday for our next lecture. Remember, no classes Monday. We'll send people with Monday tutes and labs email. Also, course forum. Read my email to the whole class if you can't access the course forum. See you soon. Bye everyone.